Hello everyone! Today I would like to present you a paper that I summarized called Software-Defined Network Virtualization, an Architectural Framework for Integrating SDN and NFV for Service Provisioning in Future Network, created by Qiang Duan, Nirwan Ansari, and Mehmet. This paper is part of my ICT Convergence seminar class. So here is my short profile. My name is Yohana Jayanti Aruan. You can call me Cio. I came from Indonesia and I graduated from Telkom University and got my bachelor degree in electrical engineering. My hobby are hiking, playing instruments, watching movies, and something else. My work experience is I work in telecommunication company in Indonesia called Telkom Indonesia for 4 years as telecommunication engineer. And my research interest is in network architecture technology, especially in 5G ready network. Okay, before I start my presentation, I would like to share a good quote that I found. I think it inspires me a lot because it tells me to know what is my weakness so I can overcome it and achieve my goals. So it's true that you cannot expect to win unless you know why you lose. In this part, I would like to tell you the motivation and contribution why this paper is made. The drive comes as current and emerging applications demand diverse and dynamic network services, while SDN and NFV are two significant innovations in networking. The evolution of both SDN and NFV has shown strong synergy between these two paradigms. Due to this demand, integrating SDN and NFV is very important so we can exploit the advantages of both paradigms. For that reason, it is desirable to give an architectural framework combining SDN and NFV paradigms. This integration is well featured in two-dimensional model. This paper also discusses key technical challenges and future research topics related to SDN and NFV integration. In short, we need to understand the basic principle of SDN and NFV and why combining both is beneficial. SDN separate the data plane and control plane to enable centralized and programmable network control, while NFV virtualize the network function and provides more specific mechanism to decouple service function from infrastructure. And the result is SDNV, combining SDN and NFV principles into one unified network architecture which produce a better end-to-end service provisioning. Here we can see the basic principle of SDN. It permits the decoupling of the control and data planes of traditional networks. Data plane is responsible for forwarding data. Control planes generates rules via control and data plane interface such as OpenFlow. And control plane or SDN controller interacts with application layer through API. Meanwhile, NFV concept run on the decoupling of network function from proprietary hardware appliances and running them as software in virtual machines or VMS. The integration of SDN and NFV comes as limitation of SDN for service provisioning is the tight coupling between network architecture and infrastructure on both data plane and control plane. And also, NFV need management and orchestration control mechanism. So, high-level framework that provides a holistic vision about how SDN and NFV fit into unified network architecture is needed. In Figure 1, we could see two-dimensional abstraction layer. It consists of layer dimension abstract, which network function, and plane dimension abstract, which part of SDN paradigm. And in Figure 2, It clearly combining this concept by divide the service function infrastructure resources and data control plane. The result of combining SDN and NFV paradigm is shown in figure 3. We could see the key components of the SDN-V framework. The infrastructure layer comprises the physical resources of network and compute infrastructures. The virtualization layer relies abstraction of physical infrastructures into virtual resources and provides mapping between physical and virtual resources. The service layer is responsible for providing service-related functionalities. Here we can see the key features of the framework. Virtualization layer interface guarantee isolation between virtual objects. It also enables high-level abstraction of underlying network and compute infrastructure. Virtual southbound separate control and management functionalities from physical infrastructure resources and VNFS. Virtual northbound separate user application and service control or management. And the key features include support logically centralized programmable control for each infrastructure domain, allows each VN to have a central programmable VNC for service provisioning, support multi-provider service scenarios, enable the trend of unified network cloud service provisioning. We could see a use case of SDN-V framework in figure 4. The infrastructure resources and control functionalities in each domain are virtualized as VNFS and exposed via an abstract interface. The service orchestration module selects and composes the appropriate VNFS to form a forwarding graph that meets the requirement for end-to-end service delivery. And the VSF or VN management module instantiates a VN to realize this forwarding graph. So, what is the challenges and opportunities for future research? The first one is virtualization for infrastructure abstraction. We need standard platform for supporting composite service across the networking and computing domains, aka unified abstraction of heterogeneous infrastructure. And the next one is embedding virtual service function and virtual networks. It needs federated control and management of network, compute, and storage resources across autonomous domains on an internet scale. Another challenge is virtualization network constructions. Constructing VNS for meeting user requirements is a core function for future service provisioning, which may be greatly facilitated by integration of SDN and NFV following the SDN-V framework. How to give abstract description of VSF attributes, how to make VSF as available and discoverable, and how to select and compose the optimal set of VSFS are all relevant problems that need more thorough study. The next one is control management of virtual networks and virtual service functions. Control management interface on the service layer between virtual networks and their controllers has received little research attention and deserves more investigation in the future. In addition, elastic service provisioning requires flexible mechanism for scaling up or down VN control capacity and dynamically deploying and migrating VN controllers. We also see the challenge in service quality assurance in virtual network environments. Cooperation of new players such as VSF suppliers, VN operators, etc. to meet performance requirements of service provisioning is needed. And the new standard in evaluating the performance, a very interesting topic for future research. And the next challenge, and also the last challenge we found, is energy-aware network design. VSF or VN embedding in network and compute infrastructure should minimize energy consumption while meeting service quality requirements. So here's the conclusion of this paper. The first one is, this framework combines the key principles of SDN and NFV. SDN and NFV may benefit from each other and presented in two-dimensional model. This paper also gives a clear holistic vision of integrating SDN and NFV principles into unified network architecture. And the last one is, key technical challenges are also presented and open a possibility for further researches. Okay, that's all for the summary of this paper. I hope I can share a new knowledge for you all, and I wish I could see you in the next time. Thank you. Bye.